Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 77 combinations. So in previous video also, we have seen this exact same question, right? Now, in previous video, we have seen about another approach called pick and not pick approach. Now we are going to see a simpler way of approach, and they both have no relationship, but still these two are different approaches to solve this one problem. Okay, it's not mandatory to watch that approach to make sure that this approach will be understandable. Okay, you can continue this approach without knowing that approach also. Fine. That link, that video's link will be given in the description. Fine. Just see this. Given two integers n and k, return all possible combinations of k numbers chosen from the range 1, n. You may return the answer in any order. So this is what a question. The question says that we want to find the combinations. So see here, n is equal to 4 and k is equal to 2. Now, if n is equal to 4 and k is equal to 2, then I want to form with the numbers 1, 2, 3, 4. Yes, and that length should be what? Only 2. Like 1, 2, 1, 3, 1, 4, or 2, 3, 2, 4, or 3, 4, like that. Okay, that are the all possible combinations for this. What are they? 1, 2. This is a 1 combination. 1, 3. Then 1, 4. Then with the 2, I can make 2, 3, then 2, 4. Okay. With the 3, I can make only 3, 4. So these are all the possible combinations. So this should be the written answer. Now, how to do this? See here, see this recursion tree. You may take any values among them, right? What are the values? 1, 2, 3, 4. You can take any one of the values. Okay. If I take 1, you may take. If I start with 2, okay. If I start with 3, okay. If I start with 4, okay. Yes, okay. No. With this 1, what is the next value? Next value I can take. Either I can take another one. No, don't pick any one value again. Yes. So I can take 2. Okay. Then I can take 3. Okay. Then I can take 4. Any one of them I can take. Now with this 2, I can take what? 3. With this 2, I can take 4. With this 3, I can take only 4. With this 4, I cannot take anything. Because that's the last value. That's the n value, right? Okay. Now observe this carefully. 1, 2, which is what? 1, 2. Here 1, 3. Here 1, 4. Here 2, 3. Here 2, 4. Here 3, 4. So we got all the possible answer, right? So simple to understand, right? So this is my recursion tree. This is my simple recursion tree. If you understand this recursion tree, just move on and proceed with your own code. If you cannot crack code, or if you don't know how to solve that problem, just look up my upcoming another recursion tree, which is a detailed backtracking approach. Okay, I will explain this in detailed manner. Okay, let me say I have a function. What should be the parameter of the function to execute these three? To execute this recursion, what should be my parameter of this function? I can say I want a value which may be 1, 2, 3, 4. I want to keep track, and also I want an auxiliary space to do what? To do operation, like I want to store each and every value, right? Here it comes 1, so I want to store 1. Then here comes 2, so I want to store 2. So it will be 1, 2. Then I will add to the result like that. So I need an auxiliary space. Right. Now, what is my recursion tree looks like? How to start? So I should start like 1, just an auxiliary space, right? Okay. With this one, what are all the starting point? So this 1 represent what? From 1 to n, we can take any numbers. With this 1 to n, we can start with any numbers. Okay. So I can start with 1 itself. Okay. I can start with 2 itself. Okay. I can start with 3 itself. I can start with 4 itself. Whether it is correct way of writing? No. We don't write like this. Why we don't write like this level by level? Because in recursion, it only occurs like a DFS, a depth first search. It means we go up to the depth, then come again. Then go to up to the depth, then come again. In induction, we used what? A BFS approach. This is what? A queue approach. So in this approach, we will just take the level by level. This one level, this one level, this one level, like that. But in DFS approach, we will go to the depth, then come again. Then go to the depth, come again. It is what? A stack approach. This recursion is what? into the stack. That's it. Okay, now 1 comma, I will take that into my result, right? 1. Okay. Then I can start with 2. No. Only I told I am self writing wrongly. Okay. Now see here. Next step. I added 1. So it will be what? 2. It will be what? 2. Why I am writing this 2? Because initially I added this 1 here. So it's time to convert this to what? 2. So that I will make sure that I can take 2 or 3 or 4 next step. Okay. Let me take 2 at first. If I take 2, it will become 3. And here comes what? 1 and 2. I can say now, this 1 and 2 is my solution. Because what is the length? And this k is what? 2. So I will take this as a 1 result. Okay. Now again, it's time to what? Backtrack. While backtracking, what should I do? I should pop this 2 out to get the original value. Okay. Now it's time to do what? 2. I will add what? 3. I recently added what? 2. Now it's time to add what? 3. So just add it. It will be something like 3 comma. I will add 3, right? 1 comma 3. I will add 3. That's it. So if I add 3, it will be what? 4. Because I cannot add 3 again, or I cannot add 2. I only can add what? 4 or greater than 4, right? So it will be because of 4. Now see here. What is the value here? This is law of length 2. So I will take this as our result. Fine. Now again backtrack. While backtracking, what should I do? I should remove this 3 and backtrack. Okay. Now whether I can take 4? Yes, sure. You can take this 4. So 5 comma 1 comma 4. Now also it is what? Length of 2. So I will take this 1 comma 4 and I will backtrack. While backtracking, what should I do? I should pop this 4 out. Okay. For this 1, I took all combinations, right? 2, 3, 4, anything else? No. So it's time to backtrack. Okay, backtrack. While backtracking, what should I do? I should remove this 1 again. Easy, right? Now, the same thing is followed for what? 2. 1 is completed. Now it's time for 2. So f of 3 comma, I will add 2. So it will be 2. So it is what? Starting with 2. It is what? Starting with 2. Now, again, I can add what? 3. So add 3. If I add 3, it will be 4 comma. Here comes 2 comma 3. So hold on. What is the length? It is 2. So take this our result. So 2 comma 3 is my result now. Okay. I will add the result. Now it's time to backtrack. While backtracking, what should you do? I should pop this 3 out. Then I added 3 recently. Now it's add what? 4. So I will add 4. It will be like f of 5 comma. Here comes what? 2 comma 4. So this is what? Length of 2, right? So I will take this as our result. One of my result. Okay. I will backtrack. While backtracking, what should I do? I should remove this 4. Now, for this 2, I committed what? 3 and also 4, right? For this 2, I committed 3 and also 4. So it also backtrack. While backtracking, what should I do? I should remove this 2. Okay. For this 1, I committed what? 2 and also, 1 and also 2, right? So now it's time to what? 3. So f of 4 comma 3. So starting with 3, right? Now, whether I can take 1, 2, no. I can take what? 4 and 4 above. What are there? Okay, take 4. If I take 4, it will be like 5 comma 3 comma 4, right? 3 comma 4. Now, I can take this as our result, right? Okay, take this as our result. So it will be like 3 comma 4. Okay, now, whether I can go further? No. It's time to backtrack. While backtracking, this 4 will be cancelled out. Now, apart from 4, whether we have any other? No. We don't have any other, right? So it's time to what? Backtrack. Okay, backtrack. While backtracking, what should I do? I should remove this 3. Now, again, the last recursion call. What is the last recursion call? It will be like f of 5 comma. What is the value? The next value will be 4. Right? Okay. Now, whether I can go beyond this? No. There will be no more recursion call because I will take 5 or 5 more. So 5 is greater than or equal to n, right? Greater than n, right? So I should stop there. Okay, I will backtrack now. While backtracking, I should remove this 4. So now see here, what are all the values I got here as a result? 1, 2, 1, 3, 2, 4 and something. Okay, these are the same values I mentioned above, right? Can you understand this? So this is our approach. Fine, it's time to see the code. See here, this is the code, def combination of I comma auxiliary space. If the auxiliary space length is equal to k, then I should take the server result and then this dot copy of is so much important. I will tell you the importance of this copy of method. Now return for in range of I comma n plus 1, which means we are going to traverse from what? From the current I. If it is 1, we want to traverse from 1 to 4. And take each and every element as the next possible value. So I will take each and every value as the next possible value in my auxiliary space. And I will go for a recursion call. Then after finishing the recursion call, I will pop it from the auxiliary space. Right? Now, the result is equal to my empty list. Now, I am calling the combination by using what? 1 comma auxiliary space. Now, return the result. Let me submit it. Yes, it is submitted successfully. Now, let me take out this copy of method. Let me run it. While running it, it will be like output will be empty list. See here, what is the output? It is empty list. Why? Because after finishing all recursion, what is my auxiliary space value? It is empty. That's the reason why I will get answer as what? Empty. Because a list are what? Modifiable, right? If I modified in any future step, then this present step will be what? Modified. So that's the reason why we should use what? This copy of method. Right. Now it's time to see the time and space of t. What is my time velocity and space of t? If I say my time velocity and space of t, I can say my time velocity will be O of n c k into k, right? Why it is into k? Because we are pushing what? We are pushing array of size k. So that will be my into k, and this will be my combination, right? So this can be also written as n factorial divided by k factorial into n minus k factorial into k. I can write like this. Yes. And what is my space quantity? It is O of n. Because see here, I'm just inserting this one. Then I insert this one. Then I insert this one. Then I will delete this one. Then only I come back. Right? So at the max, we can have up to what? N auxiliary space. Up to what? N auxiliary space. But for this approach, we can have what? Approximately, we can have A auxiliary space. Not this N. We have A auxiliary space. Because see here, 1, 2. 1, 2. Fine. So we have only K auxiliary space. So these two are approximately equal to what? The Pirai approach of space and time complexity. These two approaches have the same space and time complexity, but still you have to know about these two approaches. It will be helpful when we are moving to the dynamic programming or in difficulty backtracking problems, right? Thank you.